Hello, this is Maz, and I'm here to explain sequences and series for the IB Mathematics exam. The first thing we should discuss this unit is the difference between a sequence and a series. A sequence is a list of terms, while a series is the sum of those terms. You can see this by my example. Now we should get into the types of sequences. An arithmetic sequence has a common difference between them. So like 21, 23, 25, the difference between them is obviously 2. So the common difference is 2. On the other hand, a geometric sequence has a common ratio between terms. So like 1, 2, 4, the common ratio is 2, because if you multiply 2 by 1, you get 2. If you multiply 2 times 2, you get 4. So that's what a geometric sequence is. There's the difference in multiplication, whereas arithmetic has a difference in addition. Most of the IB questions for sequences and series come down to using the formulas given in the data booklet. So let's look at them. The first formula is for finding the n term of an arithmetic sequence, and it's the first term plus n minus 1 in parentheses multiplied by the common difference. The second term is the sum of the n terms of an arithmetic sequence, and there are two ways to write it. I'll be using the second way, and over 2 parentheses first term plus u sub n. Let's look at an example problem. An arithmetic sequence is given by 3, 5, 7, and it's asking for the common difference, u sub n, and the sum of the 10 terms. Based on the pattern of 3, 5, 7, it's pretty easy to figure out the common differences too. For u sub n, we can use the equation, which I simplified to u sub n equals u1 plus dn minus d. Now u1 is 3 because it's the first term given, so obviously it's the first term. So, and the common difference is 2. So we get un equals 3 plus 2n minus 2. And that simplifies to u sub n equals 1 plus 2n. For the sum of the first 10 terms, we can use the formula. So S of n equals n over 2, and then we can plug in u sub 1 plus u sub n. So that's 3 plus 1 plus 2n. So plug in 10 for n, and we get 10 over 2, parentheses 4 plus 2 times 10. So S of 10 equals 5 times 24, and that is 120 because 24 times 10 is 240, and half of that is 24 times 5, and half of 240 is 120. So that was a sample arithmetic series problem of sequence and series, I guess. So now let's move on to geometric sequence problems. The formulas here for the n term of a geometric sequence are u sub n equals u1 times the common ratio raised to the n minus 1. The sum of n terms of a limited geometric sequence is u1 parentheses r to the n minus 1 divided by r minus 1, and it can be rewritten. This can actually be rewritten as you'll see to the right, but I will be using the method to the left. The sum of an infinite geometric sequence is the first term divided by 1 minus r, and that equation is actually useful even into next year when you cover infinite sequences series if you take BC calculus. So let's do a geometric sequence practice problem. First three terms of a geometric sequence are u1 equals 32, u2 equals negative 16, and u3 equals 8. So now it's asking to find the common ratio, the sixth term, sum of the first 9 terms, and the sum as the series goes to infinity. As you'll see, each term is being divided by 2, and because of the alternating signs, the common ratio is negative 1/2. To find u sub 6, we plug it into u sub n equation, which is u1 times r to the n minus 1. u1 is 32, and we just found r, and we know n is 6, so you just got to plug in the numbers. And so we get 32 times negative 1/2 to the 5th, and negative 1/2 to the 5th, 2 to the 5th is 32, So that is actually 32 times negative 1 over 32. So that simplifies to negative 1. Similarly, the sum of the limited geometric sequence, we just have to use the formula and plug in the terms. So it's 32 times 1/2 to the sixth minus 1 divided by negative 1/2 minus 1. And that simplifies to 32 times 1 over 64 minus 64 over 64 times negative 3 over 2. And to solve this, you could do the fractions, but I just put into my calculator, and I got 21. Now for s of infinity, it's first term divided by 1 minus r, so it's pretty easy. So it's 32 over 1 minus negative 1/2, so it's 32 over 3 over 2, so that's 64 over 3, what it simplifies to, which is 21 and a third. So as we can see, comparing it to s of 9, it was the sum of this series was getting close to its infinite sum. Now the final thing we have to do is find the general term for arithmetic and geometric sequences. Here I just give the formulas again, not the sum formulas, just the standard ones for the n term of arithmetic and geometric sequences. So this problem goes, find the general term u sub n for an arithmetic sequence with the u sub 7 equals 41 and u sub 13 equals 77. So because this is an equation where when you put in a certain value for n, a resulting value comes out for u sub n, it's actually, we can do coordinates. So we have 741 and 1377. To find the slope of that, or the common difference, we can use the slope formula, which is y2 minus y1 divided by x2 minus x1. So when we plug in the values, we get 77 minus 41 divided by 13 minus 6. So we get a common difference of 36 over 7. And now, in order to find the general term, we're going to need the u sub 1. So you can plug it into either u sub 7 or u sub 13. I did u sub 7. So u sub 7 equals u sub 1 plus 6 times 36 over 7. And at this point, I just stopped using fractions and put it into my calculator and got decimals. And I also plugged in 41 for u sub 7. So it's 41 equals u sub 1 plus 30.86. And if you subtract 30.86, you get u sub 1 equals 10.14. And now you can just plug it into the equation for an arithmetic sequence. You get u sub n equals 10.14 plus parentheses n minus 1, close parentheses, times 36 over 7. That's the general term for an arithmetic sequence. Next problem is find the general term u sub n of the geometric sequence. U sub 5 equals 768. U sub 7 equals 12288. Unfortunately, we can't do coordinates for this one because it's a different kind of problem based on the geometric sequence thing. What we can do is plug in the numbers. So we get 12288 equals u sub 1 r to the 6th. And we also get 768 equals u sub 1 times r to the 4th. And if we divide this, we can actually, not only can we simplify the numbers, but we cross out the u sub 1 and we simplify the r value. And using our exponent laws, we get r to the 6 divided by r sub 4, r4 equals r squared, and that is r squared equals 16. So if you take the square root, you get the common ratio is 4. Similar to last time, to find u sub 1, you got to plug in the new r value into the existing point we have. So we have to plot. So we're going to do u sub n equals u1 times r to the n minus 1 for u sub 5. U sub 5 is 768. So 768 equals u sub 1 times 4 to the 4th. Raised to the 4th. And that is actually 256. And so we're left with 768 equals 256 times u sub 1. And if we divide that, we get u sub 1 equals 3, which is a nice number. And for a general term, now that we have everything, we can just write it as u sub n equals 3 times 4 to the n minus 1. That's a general term. Basically, if you just use these equations and know everything I talked about in this video, you should be able to solve most of these problems. They're not really that complicated. In fact, I would say it's one of the easier units. So good luck.